Hi, and welcome to Calculus Examples. Today we're going to use the definition of the derivative to compute the derivative of x is equal to x times the absolute value of x. Now this function by itself looks a little bit funky, so the first thing we're going to do is break down what that function actually looks like. So we have x times the absolute value of x, and we know that the absolute value of x is a piecewise function. That means that if x is bigger than or equal to 0, it's positive. And if x is less than 0, our outcome is negative. So another way of writing this out, I'm going to do it twice here, x times x, so we get x squared if x is bigger than or equal to 0, and negative x squared if x is less than 0. All right, so we know that this is what our function looks like. The next step is we are asked to use the definition of the derivative. You see those words, you ought to start thinking limits for sure. So our derivative f prime of x is the limit as h goes to 0 of f of x plus h minus f of x all over h. So here's the limit that we're going to use. And we're going to use this definition and the equation that we put together to figure out what the derivative of our function is. Now, because our function is a piecewise function, our solution is also going to be piecewise. So we are going to break this down into three cases. And the third case is going to be x is equal to 0 because things are a little bit funky there. So if x is bigger than 0, that's going to be our first case. And if it's bigger than 0, right, we're looking at this, which means we're looking at x squared. So our f prime of x is our limit as h goes to 0 of x plus h quantity squared minus x squared all over h, right? And so notice what we're doing is we're taking our x squared, and instead of x, we put in x plus h, and we square that quantity. And then x squared for our second bit and h for the last bit. We are going to distribute that. So this is going to give us, and I'm going to write this out in two steps just so that you see, as you get more comfortable with this, you can go ahead and do it in one step because it's very quick and easy. The thing is, you have to remember the interior stuff when you multiply this out, and that is what most students forget. So we're going to get the limit as h goes to 0 of x squared plus xh plus hx plus h squared minus x squared over h. I'm going to simplify it once more. Actually, we're going to simplify it twice. That stuff in the middle means that we have 2 times xh plus h squared minus x squared. And it is that middle stuff, that 2xh, that most people forget. We have a positive and a minus x squared, so those are going to cancel. And what we're going to end up with is the limit as h goes to 0 of 2xh plus h squared all over h. We can yank out a copy of h on our numerator because now the two terms that are left over both have an h involved in them, which means that those cancel. And we are left with the limit as h goes to 0 of 2x plus h, which is 2x. So there is our solution if x is equal to 0. So that's our first derivative. Our second case is going to be when x is less than 0. And let's get a different color for that. So when x is less than 0, we're looking at the function negative x squared. So when we pop things into our derivative function here, we're going to put a negative sign out front, and we're going to square everything that we tuck in there, so that x plus h. So let's look at our limit in that case, we have h goes to 0. We have a negative x plus h squared minus, and now here's where it gets a little bit tricky because now we have a minus negative x squared all over h. Double negative, this turns into a positive. So we have the limit as x goes to 0 all over h. Now I'm going to do the middle part here a little bit quicker here. We have x plus h quantity squared. We saw that above. That gives us x squared plus 2xh plus h squared. I'll just pop that in there. And then we want to distribute that negative sign. So remember that negative sign goes out to 3 separate parts here. So we have the limit as h goes to 0 of negative x squared minus 2xh minus h squared plus x squared. So now notice we can cancel out our x squareds again, just like we did in the previous part. And now we get limit as h goes to 0 of negative 2xh minus h squared. We can pull out an h, over h, there we go. So h negative 2x minus h all over h. Our h's will cancel. And isn't this lovely? Now we have the limit as h goes to 0 of negative 2x minus h. And the h disappears when we go to 0. So our derivative when x is negative is going to be a negative 2x. So that's our second case. Now we have one more case that's going to happen. And this one, let's go on to the next page. If x is equal to 0, and we want to do this one slightly different. We're going to put it out slightly different, but it's still going to have the similar setup and everything. So we have limit as h goes to 0, and I'm actually going to go through and write out this in terms of the limit, just so that we see it. F of 0, and then we'll keep on adding stuff in. So I put out our function this first time here. So this gives us f of h minus, and f of 0, when we plug 0 into our function, we know that we get 0. So that is just going to kind of disappear there. And as far as f of h goes, if we plug that in, we get h times the absolute value of h. And we're dividing that by h. So our h's disappear. We get the limit as h goes to 0 of our absolute value of h. And we know, in fact, you can just look at a graph of the absolute value of x, or h in this case. We see that the limit as h goes to 0 from both sides, it approaches 0. So our solution for part 3 is going to be 0. So that's our third case. So f prime of x is equal to, we have 3 cases. We have a positive 2x if x is positive, negative 2x if x is negative, and we just had to double check and make sure that what we thought happens actually does happen. If x is 0, it is actually going to be 0. We want to do that extra check there. All right, thank you for listening.